Hey everyone, welcome back to DevOps Talk, and this is day 7 of our Docker Workshop series. If you are new to this video, you can check out all the previous session in the Docker Workshop playlist or Docker Workshop course in my channel, or I'll also link it in the description below, so don't forget to check the previous video. And so far you have learned how Docker works, how to write Docker files, and how to build, tag and publish the images. And now it's time to bring those images to life by actually running the containers. Till now you know containers are lightweight, consistent and portable. But once you start working on the real world projects, you quickly realize that running a single container is just the beginning. And you need to understand how containers connects to the outside world, how they communicate with each other, and how their data survives even after the container stops or restarts. So in this session, we'll break down the 5 core building blocks that every real containerized application relies on, which is publishing and exposing the pods. The second one will be overriding containers default, where we'll see how to override the default env variables, runtime behavior and all. And the number third will be persisting container data, where we will be using volumes to store our data safely. And the fourth one will be sharing local files with containers, where we will be using bind mounts and real time access. And the fifth one will be managing multi-container application with Docker Compose. Yes, we'll see Docker Compose in this video as our fifth topic, where we'll be running complex setups with single YAML file. Alright, so by the end of this video, you will clearly see how all these pieces connect to build scalable, flexible and production ready containerized application. So without wasting any more time, let's dive into the video. So the first topic will be pod publishing. As I told you, our first topic is pod publishing. And now let's understand the idea behind it. And if you have followed the earlier steps, you already know that the containers isolate each part of our application. Let's say we have a 3-tier application. One is front end, back end, and PostgreSQL database. So front end is our React front end, Python is our back end, and PostgreSQL is our database. And each lives inside its own tiny sealed chamber inside our host machine. Okay, and this keeps things consistent and secure. It's already secured. You can see these things already secured, but it also means that you can't reach the services which are running inside your laptop or inside your host as you run these as containers. For example, if you are running a web app inside your container, it doesn't magically make it available to your browser. Let's say you deployed this and you want to access it from your browser. Will it available? No, right? Until and unless we'll publish those pods, it won't exist to your browser. So that's why pod publishing exists. And what is pod publishing? So pod publishing creates a tunnel from your host machine to a pod inside a container like this. Like this, it will create a tunnel for you. I'll just repeat that again. Pod publishing creates a tunnel from your host machine to a pod inside a container. It tells Docker whenever someone hits port X, let's say this is port X, on my machine, forward the traffic to port Y inside the container. This will be your host port and this will be your container port. So you configure the rule when starting the container using -p or -- publish flag. So this will be the command look like docker run -d for detached mode and -p for publishing the port, and the left side will be the host port and the right side will be the container port, and later you can add another arguments. So this is one example of pod publishing. Now anything sent to your local host 8080 on your Linux machine will get forwarded into port 80 of the container. This is port 80 where we are running an Nginx server. So whenever you type localhost, because we are running that container in our local machine, whenever if you open your browser and type localhost colon 8080, that will be forwarded to our container. And why it happened? Because we are publishing the container is like that. And one important note, whenever you publish a port, it becomes reachable on all network interfaces by default. That means anyone who can reach your machine can reach that port. So it's recommended to never expose your databases or sensitive internal components publicly. So if your friend can access to your Linux host, they can access to your container. So that was the important note tells about. Let's go to my GitHub repository and let's see what else is there in port publishing. So this part I already explained you what is port publishing and the meaning of the components. Let's see what it tells about letting Docker choose the host port, which is ephemeral port. Sometimes you don't care which port is used, you just want the container port to be accessible. You can let Docker assign a random high numbered port. So when you execute the command docker run -p 80 nginx, where nginx is the image, so here we are not providing any host port. And now if you run docker ps, you will see something like this. So Docker by default assign an ephemeral port to your container. This means port 54772 on your Linux host now maps to 80 inside the container. You specified -p, that means Docker automatically picks an ephemeral port and assign to your container. And this 80 will be the container port. And when you run docker ps, the port 54772 will be your host port. That means if you run localhost 54772, you will be able to access nginx. Now publishing all exposed ports automatically. When building images, developer may declare ports using expose instruction. These ports are not published by default. You can publish all exposed ports using docker run -P image name. So that where capital P, as I said, it's uppercase, which assigns random host ports for each export container port. That means if you specify -p over here, then whatever the developer mentioned in the expose instruction, that will be get exposed. Let's see the lab. We already installed Docker in our previous lesson. So now let's go and run a container by publishing a port. Let's say I'll use an image from the Docker hub whose name is welcome to Docker. Let's directly run the image. I'll type docker run -d. I want to run in detached mode, and -p, or you can use --publish. And now I'll provide my host port and the container port. I want the application to be accessed from the host as port 8080. Then I'll provide the image name. I'll provide the image name docker/welcome to Docker. So the port 8080 is our host port, our Linux host port, and the 80 port will used inside container by the web app. Let's hit enter. You can see now it's pulling from Docker Hub. Alright, it's already pulled. And let's see if our container is running. To see that, as I already told you, you have to use docker ps command. And you can see it's already running on 8080 port on our Linux host, and port 80 will be exposed by the container. Let's see, let's go to our browser and let's type localhost 8080. And now we successfully published a container. I mean, we published a port and mapped our host port to our container port. Let's move to our topic number 2. So the next topic is overriding container defaults. Before that, let's see How Docker starts a container. Let's say here you have a container, and when a container boots up, it runs a specific application or command. Let's say here we have an application called PostgreSQL. So when it boots up, it runs this application and it runs some certain commands. And the executable comes from the image configuration. Like to create this image, you would have write a Docker file. And in the Docker file, we have CMD and entry point. Alright. So when this image boots up, that means it runs a container, the executable comes from this image Docker file. And this container also inherit a set of sensible defaults, like it would have networking, resources, environment variables, and many more. So however, you can override these default networking, resources, or env variables, and you can fine tune the behavior. Let's say it has a network, it has some env variables. We can override those defaults. For example, you want to run multiple instances of this container, and obviously we will be using different pods because it's not possible to run the same instance, run multiple instances of the same container with same pod. So you may want to run multiple instances of this database, and you are, let's say you are expecting, that is the number one reason. And the second reason will be you are expecting heavy workload, so you may need to increase the memory, and the CPU limit of this particular container. And the third reason will be you may want to pass some secret or configs, or let's say you want to inject some env variables. And to achieve that, the docker run command gives you the powerful flags to modify this behavior instantly. So for the first reason, I told you, you can run two identical services, like two Postgres containers on the same port. So for the first one, for running two identical services like two Postgres containers, as I told you, on the same port if you run, then it will cause conflicts. So you can map containers ports to different host port using -p, as we saw already what -p does. But to run multiple containers, you can use different host port, and the container port will be the same whatever you mentioned in the docker file. But the host port for multiple Postgres instance, you can change the host port, and this lets you run multiple instances without any collision. And for the environment variables, you can inject environment variables directly with -e flag. And inside the container, you will see, if you execute this command inside the container, you will see something like this. If you go inside the container and do exec, you will see something like foo is equal to bar. And instead of adding multiple env variable, we can use, or we can supply a full .env file like this. Instead of adding multiple env variables, you can use this env file, and we can pass the env file in the command line itself. And this helps you to keep your command line clean and organized. And let's say if you want to restrict resource usage, then Docker allows resource control through -memory and -cpu flag. And this limits the container to use only 512 MB of RAM and half of a CPU core. And it is useful for shared servers or resource sensitive environments. And this is the additional thing which I have mentioned. If you want to watch real-time CPU, memory, or network usage, you can use Docker stat commands. And this will help you to decide whether to increase or reduce allocated resources. Alright, let's see all these things in our lab section. Okay, so let's run multiple Postgres instances. So to start the first Postgres container, I'll just copy the command from the slide which I showed you. I'll just copy the command and paste it here. So here, this runs Postgres on 5432, both 5432 on host port and 5432 for container port. So this will run fine. Let's hit the enter button and let's see. And it started pulling and downloading the image from the Docker Hub registry. Now you can see if I'll explain this. You can see I am executing docker run -d and I am having env variables over here. The env variable is Postgres password and I am storing the value, and the port I have mentioned 5432 and 5432 and the image name is Postgres. Alright, so in this command the env variable also there. Alright, so now it has finished all the steps. Now let's do docker ps. So the container is running. Now let's go and start a second container on a different host port. I'll just hit up arrow and I'll just change the host port here. Let's say I'll change to 5433. Now here the container still listens on port 5432 internally. This is the container port 5432. So this container still listens on port 5432 internally, but now exposed on host port 5433 to avoid the conflict. Here we have mentioned, right? And both containers now will run independently. Let's run this container as well. Okay. Now let's go and hit docker ps. You can see both the containers are running. One is 5432 and another one is 5433. Alright, I'll just clear this out. So the first step is now finished. So in the first step I want to tell you some more interesting stuff, which is Docker network. So going forward we'll see more about Docker network, but I'll just tell you in a shorter way. So by default these containers join the default bridge network and it works fine. But for better isolation and container to container communication, a custom network is more flexible. So I'll create a custom network. To create a custom network in Docker, you can use docker network command. Docker network create. Let's say I'll name it as my network. You can create a Docker network like this. Don't worry, we'll cover more about Docker network in upcoming session. Now let's verify it. To verify, type docker network ls. You can see my network is here. This one. Now let's run a Postgres on this custom network. I'll just hit up arrow and I'll find that command. Here it is. Now I'll run another container on this network. 54. Let's say I'll expose it via port 5434. And to run this container on the custom network, you can add the argument like --network and you can specify the network, my network. Alright, and this will bind the host port with 5434 and it will connect the container to my network. And we can confirm this using docker network inspect my network. You can see the network ID, the driver, the gateway, everything is here. So the difference between the default bridge and the custom network is that first point will be the DNS resolution. So the default bridge, they communicate only by IP, but the custom network, the containers can use the names, which is much easier. And the isolation part, in the default bridge, all containers end up on the same shared network unless specified. And in the custom network, only containers you attach belong to it, they only get connected. And it improves the isolation. Now let's clear this out and let's see the resource management, which I told you here. I have already showed you the env variables and the network ports. Additionally, I showed you the Docker containers, and env file is very straightforward. Now let's see this one, how we can restrict our resource usage. So the containers need manual limits if you want safety in shared environments. Let's say you want to give only let's say half of a core CPU and some limited RAM or memory, so you can use this command, the command I showed you. I'll just copy and paste. Here we are giving the Postgres container to use half of a core CPU, and we are capping the RAM usage to 512 MB, and it will be very perfect for preventing runaway workloads, and it has been created. Let's verify that using docker ps command. You can see this fellow is just now created 10 seconds ago. Alright, let's clear this out. Now let's see how you can use docker stats command to view all the resource usage of the containers. You can simply do docker stats to view it, and you can see based on our container name and container ID, you can see the CPU usage, memory usage, or limit if we have set. So for the last one we had set the limit for memory usage and CPU usage, so it's showing, and rest of the container has by default. Alright, so this way you can use docker stat command. To exit from this, you can just simply do Control C, and I'll just clear this out. Alright, so let's move to the third topic, which is persisting container data. So let's see persisting container data. We'll understand how containers handle files. So containers always start with whatever files and configuration are packaged inside their image. Once the container is running, the container can freely create, modify and delete its internal files. But this is only in containers own writable layer. So we know that once we create a container creates its own writable layer, and inside that whatever files or configs we have provided in Docker image as a blueprint, the same thing the writable layer creates it, and this storage is temporary. Okay, so this storage is temporary. When you remove the container, let's say this container is running and you just stopped the container or then remove the container using docker rm command, all the changes will vanish with it. That means whatever files or configs that you have, those will get erased. Okay, and that's good for clean and repeatable environments, but it's not so great when you need a long-term data. Let's say you have a database and the database must survive the restarts. So in that case, this is a problem, right? So how do we avoid losing important files? And that's where the volume comes in. So docker volume gives you a dependable storage area that exists independently of any single container. So this is our volume. Let's say this is our volume. All right, and instead of creating it inside the container, we will create it outside. So this will give a dependable storage, but it is independent from the container. So think of it as a connecting a directory inside the container to a storage. This is a storage, but we are connecting a directory inside the container, and this is managed by docker. This is managed by docker but outside of the container, which is inside our host. So first we will create a volume, and this volume is outside of our container. Then we will connect or mount this directory within this directory inside container, and this storage location, this volume will managed by docker, which is outside of the container. It's clear, right? Cool. So to create a container, we can use docker volume create, then the volume name. Let's say I have created a log data volume here, which you can see in this image. I created a log data volume using docker volume create command, and then to mount that we will run docker run -d in for detached mode, -p for publish, 8080 and 80 for the container, this 8080 for the host, and -v for volume. To mount that you can use -v, and then log data, which is this volume name, and we'll mount that to the logs directory inside the container. So this volume will get mounted inside the log directory in the container. Then this is the image name. And if you run this command and if you haven't created a volume, then this command will create this log data volume if it is doesn't exist. And then everything is written to this logs directory or logs file inside this container. It will directly goes to this volume and it will stay there whether the container is restarted or deleted. Then you can create a brand new container and mount the same volume, and all files will be available in this container. And similarly, you can mount the same volume into multiple containers. So all the container will have the same data. Whatever data is inside this log data volume, the same data will be available for these containers. And this setup is useful for log processing systems or data pipelines. Alright. And now let's see how to manage volumes. To list volumes, all the volumes, you can use docker volume ls command. To remove a volume, you can use docker volume rm, then the volume name. To delete all the volumes which are not currently attached to any container, you can use docker volume prune command. Alright, I hope you got some idea about docker volume and what it does and how it works. Let's see the lab section. So to give you a recap, whenever we create a container, it always starts with whatever file and configuration are packaged inside that image. So you create an image, then you created a container out of the image, then whatever you mentioned in the image, those are the files or configs are stored in your container. And container manage its own writable layer. So if you create, modify or delete, it's inside the container. And if the container is removed, all the storage, all the data inside it get erased. So this is a problem for like database or somewhere where we need to persist our data. So for that thing, the volume comes in. We create a volume outside of the container which is managed by docker. Then after creating the volume, we'll mount a directory inside the container to that volume. So whenever this directory or this file has some data, it will directly store into that volume that we have created. And now if this container is get erased or removed, then the data is persisted in the volume. Then if we create a brand new container and if we mount that into that volume, then that container has the data whichever this container is created. Similarly, we can mount multiple container with the same volume. Now if we remove the container, then the volume remains and the new container has the data. And these are the commands to create and mount the volume. Now to manage the volume, we can list all the volumes using docker volume ls command. So we can remove the volume using docker volume rm command, and we can prune all the volumes which are not currently attached using docker volume prune command. Alright, so let's see a quick lab for docker volumes. So in this lab, we'll create the same Postgres container and we'll take the example of the Postgres container for docker volume. So let's run the Postgres container. So by default, before that I want to mention that by default, when you run Postgres container, so by default inside the container, Postgres stores its data inside this directory where lib/lib then /postgresql/data. So inside this directory, Postgres stores its data. Alright. So if we attach a volume to this directory, and we'll make our database persistent, isn't it? As I explained you earlier. So this is how volume works. So now let's run a container, docker run. I'll name the container as db. Then I'll set an environment variable Postgres. Let's say I'll set the password is equal to secret. Then -d, and then here I'll attach the volume. I'll create a volume called Postgres underscore data. Notice that key I did not create any volume, but I told you if you directly mention and directly mount that volume, if the volume doesn't exist in your host, then Docker will create that volume as well. All right. Then I'll mount that volume to the directory which I told you, var lib and then Postgres QL. All right. Then the image. Let's run this. Hit enter. And now it starts the Postgres in the background. It sets the authentication password which I gave here. The name is secret, and mounts the Postgres data volume where Postgres stores its database file. All right. Let's see Docker volume ls. You can see a volume is here, Postgres data. Cool. Let me just clear this out. Then and we'll just confirm that our container is running or not. Docker ps. Yeah, it is running. Now let's connect to the database. Docker exec -it, then the name is db psql for the client, and -u. By defining -u, I'll give the username. The default username is Postgres. Alright. Now inside the PostgreSQL cell, we will create a table and add some rows. I'll just copy the commands from the GitHub repository. You can copy it from there as well. Okay. I'll mention that GitHub repository in the description. I'll just copy paste. So this is the command to create a table, and the task has finished work, have fun. Alright. Hit enter and create the table and the rows. Alright. Now verify the data using this command. Select star from tasks. Now you can see the rows are there. 2 rows are there, finish work and have fun. Alright. So these are 2 rows. Now exit from that container or from the cell. To exit, you can type \and q to quit from the cell. Alright. Now let's stop the container and remove the container. To stop the container, you can use docker stop, then the name of the container, or you can use the ID. I have the name, so I use the name. Then let's remove the container. Docker rm db. Alright, now the container is removed. There are no containers are running now. Now let's start a new container. I'll use the previous command which I used. Yeah, this command, but instead of db, I'll use the name as new db. New -db. And rest the command stays the same. No, I'll Okay, new DB, and I'll remove the env variable, which is Postgres password. Why I am removing that? Because we don't need Postgres password environment variable this time. It only applies when initializing a new database. So we already created a new database in the previous container, and this time we don't require it. Alright, now rest of the command stays the same. New db -dv, then we are mounting our Postgres data inside this container, then we are giving the image. Alright, let's hit enter and create the new container. Let's verify docker ps. Yes, it is running. Now let's confirm whether the data is exist or not. Let me grab the older one. Yes, our container name was new db, new -db. Now just copy this command, select star from tasks, and let's see, and let's verify whether the same rows are available in this container. You see, it's already there. That means the old volume is now mounted to this, and we have persisted our data. So I hope you got some idea how you can persist your data across the container using Docker volumes. Now let's see, our work is done. Now let's see how we can delete a volume, and we ensure no container is using it. So before deleting a volume, just ensure that no container is using it. If your container is still running, then you can stop the container first, then delete the volume. Okay, I have removed the container. Now I'll delete the volume. Alright, I have removed it. Now you can delete all unused volumes. To do that, you can use docker prune volume command. Sorry, docker volume prune command. Just type y. Now to check volume ls. These are all used, so this hasn't removed, but all the unused volume has been removed now. And that's it for docker volume. Let's see the another one, which is sharing local files with containers. So now we'll see sharing local files within the containers. Before that, before going to that lab, we will just understand why containers can't access or can't see our host files by default. Alright, so we know containers run in isolation. That till now we know that containers run in isolation, and each one comes with all the dependencies it needs, which is bundled into the image, and they don't rely on anything installed on the host machine, right? So this container is already bundled whatever is in the image. So from by using that image, it builds a container, and this container doesn't rely on the host machine file system. This isolation prevents conflicts and keeps environment consistent, right? So till now we already know that, but there is a downside. A container cannot automatically access the files on our host machine, that we know. But imagine running a web application container. Let's say this is our Nginx web application. This is our Nginx web application, and this container or this app needs a configuration file which is stored on our host. Like it can be a database credential or a API keys or kind of secrets or other kind of sensitive settings. Okay, but if we add those secrets into that image, then we can't really share this image in the public registries, because that is not the best practices, right? And that would be unsafe. So we can't really add those secrets or API keys into our image so that container can use. To solve this, Docker provides two mechanisms that bridge this gap between container isolation and host system. And those two mechanisms are volumes and bind mounts. Alright, so we'll see the difference. What is the difference between volumes and bind mounts? So there are different ways we can share the files between host and containers. One is volume and another one is bind mounts. So by using these two mechanisms, we can share the files between host and the containers, right? So what is volume? So volume is best when you need persistent data that lives outside the container lifecycle. And I showed you just now what is a volume and how we can use it. So volume is basically needed when we need a persistent data and which lives outside the container lifecycle. Alright, which I have mentioned it here. And it is managed entirely by Docker. I told you it is managed entirely by Docker. Docker only create this volume and Docker only manage it, and by using the Docker create volume command we can create this volume. Or if we are mapping it directly, then Docker internally creates the volume and map or mount to the container. Alright, and this is ideal for applications like databases. So we used Postgres database with volumes, so it is applicable for that kind of use case, and is more portable and recommended for production use. Alright, alright. So this is ideal for database, and we use it for persistent data. Whereas bind mounts, it connect a specific file or folder on our host directly into running container. So let's say you have a file in your host machine and you want to mount this host file or this path directly to the container path. In that case, bind mount helps us to do that. And it is great for working with live code in development. Like let's say you are developing some application and you want to see the live update of it, then you can just mount that path, host path, where you are adding that files, configuration files for developing the app, and you can mount that to container. Then whenever you change something here, the same change is reflected to this path, that container path. Okay, and it has direct link to container, and it has real-time access to host files. So as I mentioned, whenever you change something here in the host file, it will directly reflect in this path, or it's vice versa. Whenever you change something here, it will directly reflect to this path. Like bind mount act like a direct portal between your system and the container. Changes on either side are immediately reflected on the other side. So these are the different mechanisms for sharing the files or directories between host and the container. Alright, now there are different ways to attach those files to the container, which is v and hyphen hyphen mount. Let me go to the slide. So using v and mount, so both v and hyphen mount attach files directories to the container, but they behave differently. What is the difference? Let me explain you. So hyphen v provides a simpler syntax, and Docker creates host directory if it is missing. So when you run docker run hyphen v, then when you give host path, and if this host path is missing, then Docker automatically creates it. Why? Because Docker only manages this. And this is good for quick development work. Let's say we want to quickly set up a host path and container path, and we want to bind them together, then this will be very useful because it automatically creates it. Whereas mount is more robust and explicit, often for production. Why? It reduces mistake and increase safety, because when you create or mount using hyphen mount command, then if the directory is missing, then it will throw some error. So you have to explicitly create a directory and then mount it to the container. So this is more explicit and error prone. If the host path is missing, then it will show the error. So -v is for simpler task. -mount is for safety and precision. By using both two methods, you can mount a directory or a path or a folder, whatever you can say. You can directly mount from your host file to the container. Previously I have showed you that you can use Docker volume. So whenever you will use -v, so Docker will create a volume and that volume will get mounted inside the container. But when you give -v then host path, Docker will create a path for you and that path will mount inside the container whatever path you will be mentioning here. So -v, if you are giving like this, then it will create a new volume. And if you are giving the path, then it will create a path in the host machine. I hope this is clear. And after that we will see permission mode. So there are certain permission modes which are read only and read and write. So you can specify whether the container can read or modify files. So the example read and write command is, let's say you are trying to run one Nginx app, and in that app you want to give read and write permission. So here you will give -v and host directory or container directory. Then after that, using that colon, you can give the short form read write or RO for read only. Then the image name. This will be the image name. So read only, bind mounts, prevent accidental modification of host file from inside the container. Whereas read write bind mounts let the container edit or delete the files and those changes are reflected on the host. So if you are giving only read only permission, then the container directory can't write that file, can't write any write action in the file, so that your host directory will not get affected. But if you are giving read write permission, then the container has the permission to read, write and edit or delete all the permission. Alright, so you have to choose wisely based on your workflow. Okay, alright, so let's go to our lab section and we'll see the same thing in practical, and we'll bind mount a web page into an HTTP container and we'll see how it works. So we'll run a HTTP container. I'll run that using docker command, docker run -d-p for port publishing. Then I'll give the host port here. This will be my host port and port 80 will be my container port, and I'll give the name as, let's say, my site, and then the image httpd colon 2.4. I'll take 2.4 version of the image, and this will run Apache in the background and it publishes the container port 80 to the host port 8080. Cool. Let's run it. Oh, I'm sorry, I just forgot to mention the name argument. I mean name flag hyphen name my site. So it shows that my site dot latest try to find it out, but that is not available. So you have to mention hyphen name flag, then my site, whatever your container name you want to be. Then hit enter. Now it's pulling the image and downloading. Alright, let's see if our container is running. Docker ps, yeah, it is running. Now let's try to access that. Curl localhost 8080. Alright, it is working. Now let's practice our bind mounts, or how we can mount a directory from our host to the container. Let's prepare a host directory. Alright, so this is working, this image is working. We can delete the container now. You can use docker stop, then the image name, and then you can use docker rm. Alright, now we'll just create a directory. Let's say I'll create mkdir public html. My directory name will be public html, public underscore html. Now I'll cd into that. Now here I'll create one index.html file. I'll use vi, then index.html, and inside that I'll copy and paste some HTML command, so that we'll use the HTTPD container to serve our HTML file. Instead of the default page, it will serve our index.html file. This is an HTML file. I'll just create and save it. Alright, let me clear this out. Cool. Now we have the index.html. Now let's run the container with the bind mount option. Now let's run our docker command. Docker run -d, then hyphen name I'll provide. Let's say I'll use the previous one, my site, and then -p, then use port 8080, which is mapped to port 80 in the container. Then here it comes the bind mount. I'll use -v, then after that once it is done, I'll use the -mount option. Then I'll mention -v, and here you have to give the host path in which you want to mount to the container directory. Alright, so here my index.html is here in the current directory, so you can paste dot here, otherwise you can give the absolute path. So I'll give dot for the current directory, then colon, and followed by, and in HTTPD it takes the HTML file and serve from this path, user, and then local and apache 2, and then htdocs. Then we'll use the same image, httpd, the version is 2.4. Cool, this is the command, and we are using -v flag for bind mount. Now just hit enter. Alright, it is done. Let's see if our container is running using docker ps command. Yeah, it is running. Now let's see if we can access the app, or we can curl it. I'll use curl, then localhost, then port 8080. Alright, we can access it. You can directly access it from the browser itself. Let me open the browser, and here I'll use localhost 8080. Alright, we can access it. Now let's change the content a bit from the host, and we'll hit the same endpoint again, and it will verify, and we will verify if it is reflecting, because that's what we have discussed. Using this bind mount, we can directly change something here, and that should reflect in the containers directory path. Alright, and that's why we are using this method. So let me change the index.html a bit, and here let's say I'll just edit this one, that last line, hello from, let's say I'll use DevOps talk, and I'll save and exit. Now we'll go here and we'll just refresh this. You see, so this is called development workflow. Let's say you are developing something and you want to see whether it is reflecting and how it is reacting in the web page. So this way you can use the bind mount option or the volume -v option to do such kind of stuff. Alright, now let's see how we can use -mount instead of v. And this step would be almost the same as volume, but the syntax changes slightly when you are using --mount command. Mount command. I'll stop the container which is running now, and we'll use and we'll deploy the same container but using the mount flag. Docker rm my site. Cool. Let me clear this out. Okay. Now let's use the mount flag. To use that, first I'll use docker run So till here it is as same as the -v command. Now let's use --mount instead of -v. We'll use --mount, and the type will mention as bind. --mount type is equal to bind, and here we have to mention the source. Source is equal to, so in the same directory we have our index.html file, but if you have some another directory, then you have to give the absolute path. So I'll use that inbuilt env variable called pwd in Linux, and I can give here pwd, so it will take the present working directory. And here the command is a bit different than -v, so here you have to mention target is equal to the same target we have to give from where our container will take the index.html, or the application HTTPD application will serve the index file or the HTML file. So I'll provide that same particular file, user, then local, and after that we'll mention the image. Here the type is bind, so it bind mount from host to container, and the source is pwd, the current host directory where our index.html is available, then the target, the path inside the container where Apache serve the files. Alright, so you can directly use this command, or if you want to enable the permission modes, then here you can write by giving comma. You can use rw or ro, whichever permission you want to give to your container to edit or delete or modify the file, you can give the permission. So this is optional, but you should know about it. Now let's hit enter and create the container. Sorry, I did a typo here. httpd, yes, now it should run. Cool. Let's use docker ps to check whether it is running. Yes, it is running. Now let's go and access our file, and here you can see the same index file which we changed. Now let's change something in the index.html file, and here instead of docker hello from DevOps doc, I'll keep it here it is written as welcome. I'll add some line here, welcome from docker, and I'll save and exit. Cool. I have changed this. I have changed some content inside index.html. Now just go to your browser, or you can use curl. Now here you should see something here, like the changed content should reflect here. Let's refresh this or reload this current page, and here you can see. So this way you can use the -v or --mount flag, and these are the ways you can use to share your local files from your host to the containers. So whatever is changed from the container side or the host side, it should reflect on both the sides. So this part is done. Now we'll move to the next part, which is multi-container application, and there we'll see how we can run multiple container for an application. Alright, and we'll see in details. So this part is done till here. You can go and stop this container by using docker stop, then the container name. Cool. And you can remove it. So now this part is done. After that, we will see the next part will be multi-container application. We'll see in details how it works, and why it is necessary. We'll see in details. Let's move to the next part. So now let's see how we can run multi-container application. And let's understand a problem scenario, why single container apps are easy but limited. Let's understand this scenario, then we'll go and run multi-container application. Alright, so let's say you are running a simple application inside a container. Let's say this is a container. Let's say this is a container and you are running a single application here. Alright, and which is pretty straightforward, and like it could be a Python script or a small Node.js server or even a tiny static website. So all of this run well inside this individual container with a dependency which is already bundled in. But as soon as your application grows and needs other components, like your Python data processor now needs a database, and your API server needs some authentication, and you need a reverse proxy to route the traffic. So these are the dependency now you required as soon as your application grows, and these challenges appears, and suddenly you are juggling multiple components inside a single container. So what you will do, once you need it, then once you need this, then you have to create that image like that, and you have to create like this, and in the single container your multiple components are running. Whatever is required, you are running in the single container, and this goes against the one of the Docker's best practice. And what is Docker best practices? The Docker says each container should focus on its own one responsibility. So one container should focus on one responsibility, second container should focus on the second container's responsibility. So if we are putting all the components in one container, then that is not the best practices, and you will be juggling with multiple components. So here we are trying to pack too many responsibility in one container, which leads complexity in the sense there will be large images and you got up with some errors, then you have to debug, and it's very hard to debug the components within one container. So you so then you decided to split the application into separate containers. Let's say we have Node.js backend, Nginx proxy, and Redis database. You try to split the application into separate containers. But then the next challenge appears. What is the challenge? Now here the Docker run becomes difficult to run multiple containers, and this will become painful. Why? Because there will be multiple Docker run commands. So to run each of the container you have to use multiple Docker run commands, and each of it has on pods, env variables, mounts or network configuration, and there would be some dependency issues, like some services must start before others, and managing them manually, that becomes fragile. So you have to manage everything, you have to run it, you have to manage the dependencies. Let's say your database needs to be start in prior, then your Nginx proxy, your backend. So that is painful, and you have to manage everything manually, and your scaling is also inefficient. If you want to scale just the web server, you must repeat long commands manually. All right, and the networking also manual. You have to create the network and attach each services, like this service and this service must be in the same network, then only they can communicate, isn't it? So these all things are manual, and you have to define aliases inside the container, and you have to remember later on. If you have to debug, then you have to remember all the things how they connected. And the same thing goes for data persistent. Each container needs its own volume configuration, so you have to create docker volume for each container, isn't it? You have to create all these for each container. And as the application grows, the commands become long, repetitive, and error prone, so you have to remember all this. And docker compose enters. So docker compose solves all of these problems by letting you describe your entire multi-container application in a single compose.yaml file. So whatever if you are doing it manually over here, now you have to create a docker compose file and describe entire multi-container application in the single compose file. Then you can simply use docker compose command to up and down the container in a single command. Alright, so docker compose is nothing but a Docker client, how you are using Docker. So similarly, Docker Compose is used for multi-container application to deploy all the things in a single go. Alright, so it removes all this complexity. So with Compose, all services are defined together. These all services, those are defined together. Let's say this is one service, this is one service, this is one service. We will be having one docker compose file and we will be listing all the services. Then the dependencies are clear now. The network and volumes are automatically created. When you will create the service, then the volumes and networks are already will create automatically. Then scaling is easy. You have to just use some docker compose command to scale up and scale down, and one command runs and one command shutdowns the entire application. So in short, Docker Compose brings structure and simplicity to multi-container systems. We'll see in that lab. Let's go to the lab and we'll see in all these things in action. We'll just simply see the hardware first and we'll simplify using Docker Compose. So we'll manually run the Node.js app, Redis, Nginx using Docker run, then simplify everything using Docker Compose. So we'll use the hardware, then again after that we'll simplify it, and we'll see how we can use Docker Compose to simply run those applications. So I have a sample application in this GitHub repository which I already pinned in the description. You can go and check it out. I'll just clone this repository first and then go inside that repository. So inside this repository there are two folders. One is Nginx and one is web. Let's go to Nginx, and here we'll have the Docker file. So you can build a Docker image from here itself. So just to use docker build -t nginx dot. Now the image is building. Alright, now let's go back to the web directory, and here we'll use the same command docker build, and here web, the image is web. Now we'll create a network because all containers must communicate through a shared Docker network. So you have to create a network for that. So we have created the network here. So now run the Redis container and we'll attach the Redis to the network and assign the network alias. Alright. So here is the command. I'll just copy and paste. So here we are running the Redis container, and the network we are attaching to the sample app, and the alias we are setting Redis. Cool. Alright, it is done. Now we'll run the web containers and we'll start two instances to simulate load balancing. Let's use this command for the first instance. I have used the same network so that they can communicate to each other, and I have set one network alias which is web1. And for the second instance, I have just changed the name of it. Now I will run the nginx reverse proxy and will expose it on port 80 on the host. Host and container both has port 80, and we will expose it in port 80 in the host. Alright, and I have used the same network here as well. Cool. Now let's verify it using docker ps command. Alright, all containers are running. Now let's access our application. Let's go to the browser and use localhost port 80. Why? Because our nginx reverse proxy is running on port 80. And here we can see our application and we can access it. Let's refresh this page and you will notice there will be alternate responses. See, it is load balancing. You will be see web 2 sometimes, web 1 sometimes, and that is nginx which is performing the round robin load balancing. And this is how it works. So this is our entire application, and you saw how painful it is, how we have created the network, we have attached, we have created each and every container, and we did all the setups manually. Now we can delete the containers using docker rm commands. So using docker rm -f web1 web1 web2 redis nginx. So let's delete all the containers. Cool, it is deleted now. So now let's see how we can simplify everything using docker compose. So inside that project you will find a compose file, and this file already defines all the services in the sense like redis, web2 and nginx. This is called services. All the services it already defines. In fact, it will be the host name, ports, their networks. So their networks, like when you create this, it automatically create a network and add all these services into the same network. And the port mappings, we are already adding the port mappings and restart policies, like on failure it should restart, and all the dependencies, like here you can see depends on. So all the dependencies we just wrote in the single file. And to deploy it everything at once, you just need to type a command docker compose. So docker compose is a client like docker, but it uses to deploy multi-container application. Yeah, docker compose, then you have to type up -d -build. So if an image is not built yet, then it will build, or you can simply use docker compose -d up. Now let's hit enter and see. See, all the containers are running now. Cool, it is done. Now let's go and refresh our web page. Now you see the same thing is happening like how we saw earlier. The similar counter application is working for us. And to stop and remove everything, it's just as easy. Docker compose down, and it will take all the containers down. And that's all. And this is all about running the containers. So now you know how you can run multi-container application using Docker Compose, and you know when you can use Docker Compose and when you can use simple Docker commands. So this is the end of running containers. We saw all the concepts, and I hope you understood something. you got to know something new. And that's it for day 8 of Docker Workshop. Today we went beyond running a single container and explored how real world Docker application actually work. You now understand how to publish and expose container ports, how to override default commands and configuration, how to persist data using volumes, share local files using bind mounts, and manage multiple containers together using Docker Compose. So these are the core building blocks that make containers truly production ready. And now in the next session, the actual workshop begins. We'll start walking through all the hands-on labs, combining everything we have learned so far into a complete real-world Docker setup. So if you missed any earlier topics from Docker files to image building, you will find everything in the Docker Workshop playlist on DevOps Doc channel. So if this video helped you, don't forget to like, share and subscribe, and I'll see you in the next session.